here, and I have some piece of information for you. Okay, if you want to ask question, please do it with a microphone. I will give it for you because we have a video shooting there. And if you want to ask question, please do it in English. Okay, if it's impossible, we will translate. Okay, thank you. So join me to introduce Oleg Bogut.
Hello, ladies and gentlemen. I'm really happy to see all of you here. Thank you for the chance. And let me introduce myself, just in few words. My name is Oleg. I'm a developer with more than 9 years of experience. I'm working as a senior lead developer at the Untitled software company. And I also in Drupal lections in the university. I'm a senior lecturer. I'm teaching Drupal for past 3 years. And we will talk today about search in Drupal, about search API, about available search backends, facets, and in the second part of presentation, we will talk about custom extension for Search API and other stuff like performance tweaks and other. And in the end, we'll have a little Q&A section. You will be able to answer the question. And I think next hour will be effective for all of us. So let's start. In the beginning, when we work at the project, it's usually client says, I want to have search in my site. And client knows some issues regarding this search functionality. For example, client says, I want the search, and it should be convenient, flexible, fast, and better than others. Easy, right? And as usual, we need to follow some steps to improve these features. It's standard steps like uninstall search API, select and set up search backend, set up search API servers and indexes, and set up search pages, views, facets, and other stuff. Looks very easy, right? Yeah. And in the beginning, we need to kill core search. Why? It's already in core, but it's not flexible, it's not usable, and yeah, it should be killed firstly. After that, as usual, we need to install Search API and other stuff. The better way is using Composer. For this, we have Composer command. You see Composer command for installation of Search API, for facets model, for Search API pages. And after that, we need to do basic setup. I'm not concentrating on this because it's pretty simple. It's doing using UI. And why not manually install? Because we can download these models, we can put them into models folder and other stuff. But using Composer is a Drupal way solution. And also it allows us to manage dependencies for these models. It allows us to make easier updates and for the maintaining of these features. So I prefer to doing these features by Composer. And let's check search architecture. This slides, it's for better understanding how search works and how we can interact with search backends, with processors and other stuff. As you see on this diagram, we have search backends, we have search API stuff, we have some content on the side. It can be nodes, it can be taxonomy, it can be users, paragraphs, and other stuff, entities. And here we can see how it really works. The main part of this solution is Search API. It's core module. It's a module which should be used instead of core search. It's based on cooperation with search backends. We can use multiple search backends like Apache Solr, like Elasticsearch, like database search, which also part of Search API model. And when we will check the structure of Search API, we will see that it consists of server part, which related to search backend. Server can have one or multiple indexes, which contain also fields, and the field data can be processed by processors. And after that, we can see that we have also content section. I mean Drupal content, nodes, users, paragraphs, and other entities. And these entities can be processed by processors. They can be pushed into indexes, and they can be stored into search backends. And we also see UI section in the bottom. It contains views, search pages, facets, and other stuff. And end users with their laptops or maybe mobile devices works with only UI stuff. It's maybe a little bit confused because we have too many elements on this diagram, but now we will check this in details, and you will see that it's really simple. But let's speak first about search backends. Search backends is a store for our content, the search machines, and we can use different search backends for this. We can use Apache Solr, we can use Elasticsearch, we can use database search, and let's check one by one, and let's check how it works and what is preferable for our solution. So let's check about Search API database search backend. It's a submodule of Search API. In Drupal 7 it was a separate model, but in Drupal 8 it was moved into Search API. And when we install in Search API, this search backend is already available. And what the main features of this search backend? Second, it's an easy setup of search backend because we need just only enable the model. We need minimum configuration stuff. You will see it on next slides. And it's already available. We do not need to install anything. It's already out of the box. Also, we can see other search backend. It's Apache Solr machine. The key features of this search backend is full text search. It's availability of very powerful faceted search. It's no SQL features because it's no SQL. And it's already have an ability for dynamic clustering. And after that, we will check some points about Elasticsearch backend. The key features of this search backend is distributed search, it's highlighting support, it's wildcard search, and analytical search. A lot of alternatives, right? And when we need to set up this feature from scratch, we will see that we have 3 different solutions. How to take a proper solution for this situation. What is the correct criteria for selecting of this? It's really scarred. But when we will start to set up one of these, we will see that it's not difficult on Drupal side. And regarding criteria, we need to check the details about client ideas. We need to know what actually we should implement. And if, for example, site is really simple, we have very much count of nodes, other content, we, for example, can use database search. When we need full search as key feature, for example, we can use Apache Solr. So in this situation, first of all, we need to check what actually we should implement. And, oh, sorry. I think that went wrong. And in this situation, we need to check our key points. We need to know what we should implement. And we need to just select one and install it. So let's check how to use the simplest solution. In our case, it's how to use database search backend and how to set up it from scratch and how to use it. As you see on this picture, first of all, we need to set up 2 points. We need to set up local search server and we need to set up search index. When we enabling database search, we will have the ability to create local search server, and after that we need to set up it. As you see, here you see a slide with basic setup of database search server. As you see, there we have not too many options. It's just status option. It can be enabled, disabled. We can select the backend of this server. In our case, it's only one. Okay, it's database search server. And we have just few options for configuration. In this case, it's minimum word length for full text search. It's an ability of partial search, and that's all. So as you see, it's not too scary when you started to explore it, and it's really simple tasks for manual configuration. When we doing after finishing of setup for search backend server, we need to set up second feature. It's search index. Index contains a list of fields which should be indexed, and we will have an ability to use these fields in our search. When we take a look on slide, you will see few fields. They can be added via add fields button. And you will see a few fields. It's body, it's another ID field, it's standard tag fields, it's title fields. And you can see the type column for each field. It's options how these fields can be indexed. It's full text, it's integer, string, and it can be other type. When we index a field with this option, we will have an ability to interrupt this field according to its type. And when we finish with configuration of fields in the index, we need to do some configuration for processors. As you remember, on one of the previous slides, you will see that the search API contains some elements like search server, search index, and processors. Processors allows to process the indexed field values and can doing some things for output, or maybe working with other stuff like facets, etc. And when we take a look on this slide, you will see that we enabling the simplest processor. It's highlighting. It have not many options. It's really easy. And as you see, at this moment we didn't make any operation with code. It's just UI setup without any custom code. And when we're finishing with configuring of processors, we're just running indexing. As you see on the screen, we need just to click index now, and all data which configured into search index will be indexed, and they will be available for next processing. When we have index and when we have indexed data inside it, we can work with this data. We have a lot of solutions for working with data. It can be search page module, it can be views solutions, it can be custom solutions based on custom code. But in our case, we check the solution based on search API page model. It's the simplest solution. We need to just create search IP page, and we need to set up just few options, like we need to select index, we need to check which field should be used on search page, we need to set up path, and other options like limitation for displaying, etc. And when we save the value, we will see that we have a search on site. It allows us to type some keywords, and we will see search results. We will have highlighted results. It's really simple. It looks really simple for each levels of development, especially for juniors, right? But if we need to extend it, we can add other stuff like facets. We will check how to do it. We, as you remember on one of the first slides, we also installed a facet model. And when we need to enable the facet search, we just can create the facet. We can set up facet filter for field, as you see on slide. And facet can be applied to views or search pages, or also for custom solution. When we creating the facet, we need to set up widget for this facet. It can be, for example, as you see, drop down or list of links or checkboxes or etc. And then we will have a block which can be placed on specific page. As you see here, we have the facet filters block in the left sidebar, and as you see, it really works and really simple. And after that, you have a feeling that you have set up from scratch. It really works, and each junior we can see that it's really powerful. It's really simple. It's cool. But when we try to dig inside this feature, we will see that all things looks unclear for the first view. So let's do little research how really Facet API works. When we will check the architecture of Search API, we will see that it contains different types of plugins. There are types, data types, plugin, backends, plugin, data sources, plugin, processors, etc. There are a lot of different type of plugins, but in most cases we can work with 3 types of plugins. It's backend, it's data sources, it's processors. And when we can check the definition of search API plugin. We will check how to create, how to work with really simple task. We will check how to create custom search API field, which can be used for calculation of duration of the event, when we have begin date, end date, and when we need to calculate the duration of event, and we need to have an ability to store these values inside the search API and use it. For example, on the screen, you can see a structure of very simple entity. It's node. It contains 3 fields: begin date, end date, and event description. And let's check how we can create search API plugin for custom field, for implement of this feature, for automatically calculation of duration of the event. As you see on this slide, each search API plugin, it's just a class. It have its namespace. It has its own plugin namespace, annotation, and other stuff. And let's check in details how to really create it from scratch. See, we need to define the basic structure of search API processor. As I said earlier, it's a class. So we need to define the namespace for this class. It has a typical structure. As you see, it's Drupal, my model, plugin, search API processor, namespace, and we need to use some other classes for correct implementation of this class. You have a list of these classes. After that, we need just to define class. We need to extend it from processor plugin base, and we need to create just one protect property. And after that, when we have the class skeleton, we need to move to the second step. We need to add processor annotation. It also has typical structure. As you see, it has ID. It's unique identifier for processor. It has label and description, which should be used inside the UI during configuration. We have stage options. We have hidden and lookit options, which should be used for interaction with this processor. And when we create the annotation, we can start to create separate methods of this service. So first of all, we need to implement index supporting logic. As you see, we have public static method, call it supports index. And this method allows us to use our class, our plugin, only for specific indexes. For example, when we need to use our plugin only for indexes based on nodes, and we can use this logic. Next, we need to add property definitions. In this public method, we can display, we can set up definition of field, we can see that the definition contains such fields like label, description, type, processor ID. Label and description are used for displaying inside the search index UI. Type is a specific type we should use for storing data, and processor ID is a unique identifier of the processor. And in this method allows us to define field and allows to set up the feature for storing data inside our index. And in this step, we have the most interesting method in the creation of custom field. It's a public function, public method called add fields value. In this method, we can set up which data will be stored inside the field. In this method, we can work with business logic for this our custom field. And let's check the structure of this feature. As you see, first of all, we get in the entity, we check in the type of entity, and if it's a proper entity, we can start working with fields. For example, in case of our task, we need to check if it is event entity, and if begin date and end date fields are not empty, we can to get their values. We can to check that these values are correct, so end date is greater than begin date. And after that, we can to calculate the duration of event, and you can see that we can at this point we can save the value inside our custom field, and this value will be stored inside the index. So it's all about code. Let's move to UI part. As you remember, we have index page, and as you see, in the top of this index page, we have specific new field. It's called index event duration with machine name duration field item. And as you see, this type of this field is integer, so it's the same as we have set up on this step. So the field defined in our code can be added to search index just in the same way as you can work with other fields like fields from nodes, etc. And it can be also placed in the index, and it can be used in other elements like views, like view pages, like search pages model, and other custom solutions. So let's check how to use our indexed field and how we can use it inside custom solutions. For example, let's take a look into this slide. Here you see just a view based on view index. As you see, we have a list of fields. It's just indexed fields from node, and also our custom field used processed by our custom code and placed it into view. And here you can see result of this. It's just a simple view. It's a table, and you will see begin field, begin date, end date, and duration, which was calculated inside our custom code. So you can see that it's really simple. It's not need to know any specific skills for this. Just simple operations, just working with typically solutions in code, and you can work with different tasks with different difficulties of data structure. For example, when we can use these features, why and when we need to customize, when we can use contrib solutions, when we can use customized solution. First of all, we can use custom solution when we don't have original features in contribs. For example, when you need to aggregate value, as we did in our custom code, we need to use custom solution. If you have something in search API or other contrib models, the better way is using of contribs. The other stuff when we need to customize, it's when we need to do some performance tweaks. So, customization versus contrib solutions. It's a very interesting thing. As you see, we have 3 points. As usually, when developer, for example, junior developer, starting to working with Search API, he can see that it's really simple. He can configure difficult searches just clicking things and see, wow, I can create search using Search API and other contrib things, and it's really great. I can do it. Wow, it's cool. It's first level. But when developer starting to dig inside Search API, he see that Search API contains different type of plugins. It contains a lot of other API things, and you see, wow, I can create my own solutions. I can create my own services, and it's cool. And as usual, the developer starts to create custom solution in this situation. He can do it something within contrib, but he's starting to create customs because he can. It's wrong. And after that, you can see third point. It's point of senior developer. He knows it. He can create complex solution. He can use contribs. He can use customs. But better way is create custom complex solution, use contribs and custom code, and doing it without any wow reactions. Just do what actually need. And in this case, we need to know how don't reinvent the wheel. We need to check solutions in contrib models. After that, we need to check it twice, because in most cases, it's already implemented. After that, we need to try to extend existing solution instead of creating from scratch. And the better way is to use reusing of contrib code in custom solution instead of creating from scratch. And the main case is keep it simple. Do not create any hard, difficult solutions. And some performance tweaks. It's use Search API fast for better performance. It's excluding unpublished content if we don't need to use it. It's very interesting. We do not use DB storage backend if you have too many entities, because it will work very slow. Also, we need to use caching best practices, and we need to use Ajax or asynchronous loading. It's a good trick. And if you will follow the best practices, you will be success. Questions?
First of all, thank you for your session. I believe it was very interesting and useful. I have a few questions according to CH API. First of all, when we add in new fields to the index, CH API forces us to index content. This means that we need to do this, yes? But this can be very tricky for production environment. So the question is, can you suggest some ready-to-use solution to maybe implement some condition indexing, when adding new fields to not erase all content, just maybe when we just erase that content that for which we are adding new fields, for example.
Yeah, I understand. Thank you for your question. In this case, when we need to, as I'm understanding, you need to take some just data for indexing only specific elements, items of elements. It's good from performance point of view. In this case, I prefer to use custom solution because we can check what we actually need, and we can put it inside the search index instead of index all. I think custom solution is better in this situation.
And the second question is, sometimes when we're using some kind of front-end application on JavaScript, yes, we need to have access to CH API backend. This means that we need to use or create some bridge between front-end and backend, yes. So the question is also, can you suggest some solution for it, except using some third-party services like U-Box-U or something similar?
Yep.
Thanks.
The difficult sides, we really can have the backend in Drupal and the front end on non-Drupal solution, for example, in using React. And in this case, we can take a look in the latest Drupal version. And you will see that Drupal contains very interesting module in core. It's called JSON API. And you will see that you can combine this JSON interface with Search API. It allows to easily interrupt with front-end part, because a lot of things can be configured using UI as feature, and I think it's a really good solution. Welcome. Any questions?
You said that if you have a lot of entities, it needs to go to the Solr instead of using database search, and from how many entities you have or you think you will have in the future, you prefer, you will use Solr instead of database 100, 1000, million?
Thank you for your question. It's really interesting. I said not just Solr, but we have also Elasticsearch. It's also a very good solution. But in my practice, I'm starting to use non-SQL solutions from, for example, 5 or 7 thousands of content items. Any questions?
So let me thank our speaker and give him a special certificate.
Thanks.
Thank you all and have a nice day.